In the first exercise of the second week, we're going to calculate the cost of one painting. We know its sides to be 3 and 4 centimeters, and what we would like to calculate is how much is its area, because thus, when we know the area, we know how much 1 square centimeter of its canvas costs, and we will know how much will canvas cost all in all, and we will know the material, this part of material price. Then we will calculate the boundary line around the picture, and by doing that we will know how much frame we will be using, and how much does that cost. We also need to fasten the picture to the wall. For that, these fasteners are actually behind the picture, and if we know the length of the fastener, by knowing its price, we also know the cost. Plus, no matter what the size of the painting, we always pay $900 for work. Okay, and now let's begin from the beginning. The first formula is how much is the area of the painting. We write equals and click on C5, so equal starts the calculations. Click on C5 times C6, and here it is. This will calculate 3 times 4 to be 12, and we have our canvas area. The second calculation will be equals. We want to know the boundary line, which is 4 plus 3 plus 4 plus 3. So we write equals 2 times parentheses C5 plus C6. So we take the two sides and we double them. Parentheses closed, and the formula gives us 7 plus 7 is 14. Okay, now let us enter this formula. We haven't used parentheses before here, but just as in mathematics, we want to put them around addition, and so that addition will be done first and multiplying later. Okay, now the next thing is the diagonal line behind the painting. Actually, if we want to draw this diagonal, what we need to do is insert and shapes. So this is something we don't use very often in this insert shapes command, but the shapes are here nevertheless. Excel has quite a decent drawing tool set, and we are actually, since these are the fasteners are in red, what we did was we selected the line and pressed Ctrl 1 here, and here it is, a number of new options for the drawing tools. This is the same Ctrl 1 that gave us format cells. If we take one cell and click Ctrl 1, then remember we were able to set its border, its background fill, its font, and so forth. And now if we press Ctrl 1 on a line, we will be able to set a number of properties for graphical objects. Right now we could just select line color to just take something and then show a little bit of what's being done with those tools. Okay, so we have actually drawn already those fasteners. And now comes an important part, how to calculate the length of the fastener. We know that this side here is 3 and this side is 4. And thus we can see that the 3, the 4, and the diagonal, they form what is called a right triangle. A right triangle is a triangle which contains a 90-degree angle in it. This is the 90-degree angle is here, this is 3, this is 4, and this is the diagonal. Now, in order, when we know 3 and 4 and want to calculate the diagonal, we apply Pythagorean theorem, which says that if we write 3, take it to the power of 2, or 3 squared, we get 9. And when we add to it 4 to the power of 2, or 4 squared, we get 16, and 9 plus 16 is 25. And now when we take the square root of 25, we will get the length of the diagonal behind the painting. So this is our first function for today. We write equals, and square root is written SQRT. Very often the function names in Microsoft Excel are quite intuitive. SQRT is a little bit different. It's a shorthand without vowels, so we have to remember it. And now every function was followed by parentheses so that Excel would know that it's a function we're dealing with. And now we want to take free, that is in cell C5, to the power of 2, or we want to square free. So in order to take it to the power of 2, we have to now click and hold the Alt key, which is right from the space. So it's on the left side of space. We have to hold it, and now from the right side of the keyboard, click on 94. So Alt 94 will give us the kind of roof symbol, which represents to the power of in Excel. And now we have to say number 2 in order to get it to the power of 2, so it will be squared. And of course we will prefer this Alt 94 for the reason that if we, for instance, want to take something to the 10th power, I mean, with the second power we could have written C5 times C5, but to the 10th power it's already too tedious. Okay, so we got 3 squared, and now we want to say plus C6 Alt, hold it down, 94, release Alt, we got the roof sign, and to the power of 2 again. And this all is going to be entered in the parentheses of SQRT. So 3 times 3 9, 4 times 4 16, 9 plus 16 25, and square root of it is 5. So subsequently we have actually come to the favorite right triangle of Pythagoras. Pythagoras, the ancient Greek, was actually himself a numerologist who believed in the magic of numbers. So his favorite rectangle was 3, 4, 5. Okay, and now just a few words that really we will need in our further studies, the Pythagorean theorem, because for instance there is one further exercise where we will be having a number of cities that are located in different geographical coordinates, and in case of these cities we would like to determine where our company would like to build a warehouse. And in this case we will need to start building such Pythagorean theorems, because we want to measure distances between cities. So just to show that really this Pythagorean theorem is something that comes in handy in business problems, this is one example of it. So we will need it further, but now let's continue with our present exercise. Namely, we want to calculate the exact total cost. Let's write equals, and let's take those 12 square centimeters of canvas. We want to multiply it with times $200 per square centimeter, and we got the first component of our painting's price. Plus, we want to take the boundary line, which is 14, and we want to multiply it with the price of a frame. Frame price is $1,200 per centimeter, and we get that part of our cost calculation as well. Plus, now we want to take the fastener. We want to take 5 centimeters of fastener times the price of the fastener, which is $300 per centimeter. And now, guess what? We'll have to say times 2, because there are 2 fasteners behind the painting. And now the final component is going to be plus $900 for the work. And we will have taken into account the area, the boundary line, the diagonals, and the work. And here it is. The correct answer should be 23,100. So that's the size of it. We have all the formulas written down here. This is the area, this is the boundary line, Pythagorean theorem, the total cost that we were going to calculate, and here it is. So the only thing to say about this formula is that it's a bit difficult to follow, and because it has all those C9s, C8s, and so forth. But that's the problem we're going to tackle in the next exercise.